In this video, we're going to focus on finding derivatives. Derivatives of functions that you're going to see in your calculus course. We're going to start with the derivative of constants using the power rule. Whenever you have fractions, radicals, trig functions, sine, cosine, tangent, natural log and log functions, exponential functions, e to the x, product rule, quotient rule, chain rule, implicit differentiation, derivatives for related rates, inverse functions, and how to find the derivative using the limit process. So we're going to cover all of those topics in this video. So let's begin with the basics. The derivative of any constant is 0. So let's say if you want to find the derivative of 5, it's going to be 0. The derivative of 8 is 0. The derivative of pi is a constant, it's a number, 3.14, it's going to be 0. The derivative of pi raised to the e, that's 0. The derivative of like 4e is 0. Notice that there's no variable, there's no x or y. So the derivative of any constant is just 0. Now let's say if you want to find the derivative of x squared, you can use the power rule. So what you got to do is move the 2 to the front and simply subtract the exponent by 1. So the derivative of x squared is 2x. The derivative of x cubed is 3x squared. For x to the 4th is 4x cubed. For x to the 5th, 5x to the 4th. Now let's say if we had a constant in front of it. So let's say if you want to find the derivative of 4x to the 5th. Rewrite the 4 and simply differentiate x to the 5th, which is 5x to the 4th. And then multiply the 5 and 4, and then you're going to get 20x to the 4th. So let's say if you want to differentiate 7x to the 6th. Rewrite the 7, differentiate x to the 6, which is 6x to the 5th, and then multiply 7 by 6, and then you should get 42 x to the 5th power. We'll try one more example. 8x cubed. Rewrite the constant 8, differentiate x cubed, which is 3x squared, and then 8 times 3, that's 24x squared. Now let's say if we have a polynomial function. Let's say if you want to differentiate 4x cubed plus 8x squared minus 7x plus 6. So you just got to find the derivative of each one separately. So the derivative of 4x cubed is just 4 times 3x squared. The derivative of x squared is 2x. The derivative of x is 1. And the derivative of 6 is 0. So it's going to be 12x squared plus 16x minus 7. So let's say if you want to differentiate 5x, it's simply 5. 8x is 8. 12x, the derivative is 12. Let's talk about y. If you differentiate x to the first power, using the power rule, move the 1 to the front. So we have 1x, and then subtract this exponent by 1, you get 0. Anything raised to the 0 power is 1. So x to the first power is simply 1 if you find a derivative for it. So 7x is going to be 7 times 1, which is 7. Now let's talk about finding the derivatives of fractions. So let's say if we wish to differentiate 1 over x squared. How can we do it? The first thing you want to do is rewrite the function. So basically, we're going to move the x squared to the top. When we do that, the positive 2 changes into a negative 2. And so now we can use the power rule. We're going to move the negative 2 to the front. So it's negative 2, and then x, and then subtract the exponent by 1. Negative 2 minus 1 is negative 3. So it's negative 2x to the negative third power. Then bring the x back down so that the negative exponent will become positive again. So it's negative 2 over x cubed. Let's try another example. Let's differentiate 1 over x to the third power. So again, initially rewrite it. So this is the same as x to the negative 3. Then move the negative 3 to the front. So negative 3x, subtract negative 3 by 1, negative 4, and then bring the x to the bottom. So it's going to be negative 3 over x to the 4th. So feel free to try this example. 1 over x to the 5th, and let's say 7 over x to the 6th. So initially rewrite it. This is x to the negative 5. use the power rule. So it becomes negative 5x to the minus 6, and then bring the x back to the bottom. So it's negative 5 over x to the 6th power. That's the answer. So for this one, rewrite the constant 7 and bring the x to the 6 to the top. So it's x to the negative 6. Then differentiate this part. The derivative of x to the negative 6 is negative 6x to the negative 7. Now, move the x to the bottom and multiply these two numbers. 7 times negative 6 is negative 42, divided by x to the 7. That's the answer for that one. So now let's focus on differentiating radical functions. Let's differentiate the square root of x. Now you need to know that there's a 1 here and there's an invisible 2 if it's not there. This is the index number. So if you don't see anything, it's a 2. The square root of x is the same as x to the 1/2. This number becomes the denominator. And this is the numerator of the fraction. So now we can apply the power rule. So we're going to move the 1/2 to the front, and we're going to subtract the exponent by 1. 1/2 minus 1 is the same as 1/2 minus 2 over 2. So 1 minus 2 is negative 1 over 2. So this becomes a negative 1/2. Now what we need to do next is move the x to the bottom. So it's 1 over 2x to the 1/2. Then put it back in radical form. So 1 over 2 square root of x. Let's try another example. So let's say if we wish to differentiate the cube root of x to the 4th power. So first, convert it into its exponential form. This is the same as x to the 4/3. Keep in mind, this number goes on the bottom. Then use the power rule. Move the 4/3 to the front. And then we have x subtracted by 1. So 4/3 minus 1 is the same as 4/3 minus 3 over 3. 3 over 3 is 1. So 4 minus 3 is 1 divided by 3. And since the exponent is already positive, we don't need to change it. Let's try another example. The derivative of the 7th root of x to the 3rd. So let's rewrite it. This is the same as x to the 3 over 7. So move this to the front. This is 3 over 7, and then x, subtract the exponent by 1. So 3 over 7 minus 7 over 7. 3 over 7, well 3 minus 7 is negative 4. So we have a negative exponent. So we're going to move this to the bottom. So it's going to be 3 over 7 x to the 4 over 7. Keep in mind, this number is on the bottom already. And now convert it back to its radical form. So it's 3 over 7. This is the index number. So the 7th root of x to the 4th power. That's the answer for that example. So let's see if we can put this all together. So go ahead and find the first derivative of this function. 8x to the 5th minus 3 over x cubed plus the 5th root of x to the 4th. So starting with this, we have 8 times the derivative of x to the 5th, which is 5x to the 4th. Now for this one, we have negative 3x to the minus 3. So we're going to move the negative 3 to the front. And then we have x, subtract this by 1, raised to the negative 4th. And then here, let's rewrite it. This is x to the 4/5. Move that to the front. So we have 4/5 x, subtract 4/5 by 1. 4 over 5 minus 5 over 5 is negative 1 over 5. And then move this to the bottom. So we have plus 4 over 5 x to the 1/5. So now let's simplify. 8 times 5 is 40. So we have 40x to the 4th. Negative 3 times negative 3 is positive 9. And then move the x to the bottom. So 9 divided by x to the 4th power. And then plus 4 over 5. And convert it back to radical form. The 5th root of x to the 1st power, which is just x. So that's how we can differentiate that particular function. So now let's move on to the derivative of trig functions. So let me give you the equations that you need to know. So the derivative of sine to the u is just cosine of u times u prime. The derivative of cosine u is negative sine u times u prime. And for tangent u, the derivative of tangent is secant squared u times u prime. And the derivative of cotan u is negative cosecant squared u times u prime. And for the derivative of secant u, it's secant u tangent u times u prime. And for cosecant u, it's negative cosecant u cotan u times u prime. So let's try some examples. Let's say if we want to find the derivative of sine x. The derivative of sine is cosine x, and then differentiate the inside. The derivative of x is 1. So now let's say if we want to differentiate cosine x to the third. The derivative of cosine is negative sine, and whatever the angle for cosine is, it's going to stay the same for sine. Next, differentiate the inside, x cubed. The derivative of x cubed is 3x squared. So this is u and this is u prime. So let's say if we wish to find the derivative of tangent x to the fourth. The derivative of tangent is secant squared, and keep the angle the same, so x to the fourth. Then differentiate the inside. The derivative of x to the fourth is 4x cubed. So now let's say if we want to differentiate secant 7x. The derivative of secant is secant tangent, so secant 7x tangent 7x, and then differentiate the 7x part, which is just 7. So let's try one more. Let's say if we want to differentiate cotangent of x to the fourth. The derivative of cotangent is negative cosecant squared. Then keep the angle the same, so x to the fourth, and then differentiate x to the fourth, so 4 times 4x cubed. So we can write this as negative 4x cubed cosecant squared x to the fourth power. Last one. Let's say if you wish to differentiate cosecant of x cubed plus x squared. So the derivative of cosecant is negative cosecant, keep the angle the same, times cotangent. And the angle still has to remain the same. Next, differentiate the angle. The derivative of x cubed plus x squared is 3x squared plus 2x. And it's multiplied to this, whatever that thing is, that term. Okay, let's try some more examples. So now let's focus on log functions. Here's the equation you need if you want to differentiate, let's say, natural log. The derivative of ln u is u prime over u. So let's say if you wish to differentiate ln x. The derivative of x is 1 divided by what was inside x. So if you wish to differentiate ln x squared, the derivative of x squared is 2x divided by what was inside, x squared, and you can reduce that to 2 over x. Keep in mind, you can move this 2 in front, so this is the same as 2 ln x. That's a property of natural logs, which is twice the value of this. And so that's why it's 2 over x. So let's say if you want to differentiate ln x cubed, it's going to be 3x squared over x cubed, which reduces to 3 over x. Remember, this is the same as 3 ln x. But now, let's say if you want to find the derivative of ln x to the fourth minus x cubed. So differentiate the inside, which is 3x squared, 4x cubed minus 3x squared, divided by the original, which is what's inside here, x to the fourth minus x cubed. So that's how you could find the derivative of natural log functions. But let's try one more example. What about ln sine x? Feel free to pause the video and try this example. The derivative of what's inside, the derivative of sine is cosine x divided by the original sine x, and cosine over sine is cotangent. So now what about log functions? The derivative of log base a of a u variable is very similar to a natural log. It's u prime over u, but divided by ln a as well. So let's say if you want to differentiate log 5 x cubed plus x squared. The derivative of x cubed plus x squared is 3x squared plus 2x, and then the u variable is the original, what was inside, which is x cubed plus x squared, and then times the natural log of this number, which is 5. So let's say if we wish to differentiate log 4 of x cubed. The derivative of x cubed is 3x squared divided by the original x cubed, and then times ln 4. So we could simplify it. This becomes 3 over x ln 4 if we cancel x squared from the top and the bottom. So that's how you can differentiate logs. So next, let's move on to exponential functions. The derivative of, let's say, e to the u is the same thing, e to the u times u prime. So if you wish to differentiate e to the x, it's going to be the same thing, e to the x times the derivative of x, which is 1. E to the 2x is going to be e to the 2x times the derivative of 2x, which is 2. E to the 3x is e to the 3x times 3. E to the x squared is going to be e to the x squared times the derivative of x squared, which is 2x. So let's say if we wish to differentiate e to the tangent x, it's going to be the same thing, e to the tangent x times the derivative of tan x, which is secant squared x. So e to the cosine x is going to be the same thing, e to the cosine x times the derivative of cosine, which is negative sine x. So now let's talk about how to differentiate exponential functions when we don't have the base e. So the derivative of, let's say, a to the u, where a is a constant and u is a variable, is the same thing, a to the u times u prime ln a. Now for e to the u, it was e to the u times u prime ln e. Ln e is 1, so we can ignore it. So let's say if we wish to differentiate, for example, 5 to the x, it's going to be the same thing, 5 to the x times the derivative of x, which is 1, and then times ln 5, ln of the base. So let's say if we wish to differentiate 7x squared, it's going to be the same thing, 7x squared times the derivative of x squared, which is 2x, and then ln 7. So the derivative of 8x cubed is going to be the same thing, 8x cubed times the derivative of x cubed, which is 3x squared, and then ln 8. But now let's say if we have a variable raised to a variable. So far we consider these three cases. X cubed, which is a variable raised to a constant. We can use the power rule. This is 3x squared. Now we've considered 3 to the x, a constant raised to a variable. This is 3 to the x times the derivative of x, which is 1, ln 3. But now what about this one, a variable raised to a variable? How can we differentiate that? Well, we need to use something called logarithmic differentiation. So let's say if you have y is equal to x raised to the x. The first thing we want to do is take the natural log of both sides. Then a property of logs that you can use allows this x to be moved to the front. So now you have ln y is equal to x ln x. Now you want to differentiate both sides with respect to x. The derivative of ln y with respect to x, it's going to be 1 over y. Remember, we're using u prime over u. The derivative of y is 1 divided by the original term that's inside of ln, which is y. And then whenever you differentiate a y variable with respect to x, you get dy over dx. And next we need to use the product rule, which haven't taught you yet, but I'm going to. But basically, the product rule is this. Differentiate the first part. The derivative of x is 1. Keep the second part the same, ln x, and then plus keep the first part the same, which is x, and then differentiate the second part. The derivative of ln x is 1 over x. Now your next step is to multiply both sides by y. So you get dy dx is equal to y times ln x, and then x times 1 over x is just 1. And then your last step is to replace y with what it was at the beginning. So your answer is x raised to the x ln x plus 1. Now there's an equation that you can use for these problems. So let's say if you want to differentiate let me color code it, u raised to the v. So it's going to be the same thing, u to the v, and then times v prime. Let me fix that. V prime times ln u plus v times u prime over u. So let's try an example. Let's differentiate x raised to the sine x. We're going to do this two ways. We're going to use the formula, and then we're going to use logarithmic differentiation to get the same result. So the answer is going to be the same thing, x to the sine x. Now keep in mind, u is x, v is sine. So v prime, which is the derivative of sine, that's cosine x, times ln u, u is x, so ln x, plus v, which is just sine x, times u prime. Now u is x, so we have an x on the bottom, and the derivative of x, which is u prime, is 1. So that's our answer, x sine x times cosine x ln x plus sine x divided by x. So now let's see if we can get the same result using logarithmic differentiation. So we're going to set y equal to x sine x. Then we're going to take the natural log of both sides. So ln y is equal to ln x sine x. And then we're going to move the sine to the front. So we have ln y is equal to sine x ln x. And now differentiate both sides with respect to x. The derivative of ln y is 1 over y dy dx. And here we need to use the product rule. Differentiate the first part. The derivative of sine is cosine x. Leave the second part the same, ln x. And then plus, leave the first part the same, which is sine x. And differentiate the second part, ln x, which is 1 over x. Now, our next step is to multiply both sides by y. So here it cancels. So dy dx is equal to y times cosine x ln x plus sine x divided by x. And then we can replace y with what it was, x sine x times everything we have on the inside. As you can see, the answer is the same. So for logarithmic differentiation, you can use the process, or you can use this equation to get the answer. Both ways will work. So now let's go into the product rule. I know we mentioned it already, but let me give you the equation that you need. The derivative of, let's say, u times v. So the way it works, you differentiate the first part, u prime, leave the second part the same, v, plus, leave the first part the same, and then differentiate the second part. So let's apply it. Let's say if we wish to differentiate x squared sine x. So the derivative of x squared is 2x, and then we're going to keep the second part the same, the sine x, plus the first part, which is x squared, and times the derivative of sine, which is cosine x. So that's the answer, but we can simplify it. If we can notice that we can factor out a GCF, in this case x. If we take out an x, we're left with 2 sine x plus x cosine x. So sometimes you can simplify by factoring out the GCF. Let's try another example. So let's say if we wish to differentiate x cubed e to the x squared. So differentiate the first part, the x cubed, which is 3x squared, and then keep the second part the same, e to the x squared, and then plus. Now differentiate, we'll keep the first part the same, x cubed, and then differentiate the second part. The derivative of e to the x squared is the same thing times the derivative of x squared, which is 2x. So now what we're going to do is factor out the GCF. In both terms, we can take out an x squared, and we could take out an e to the x, or e to the x squared. So we're going to factor out x squared times e to the x squared. So now if we take this term and divide it by what we factored out, the e to the x squared is gone, and the same is true for the x squared, so we're only left with 3. Now if we take this term and then divide it by a GCF, e to the x squareds cancel. We have a 2, and there's a total of 4 x's, so 2 of them cancel, leaving 2 behind. So we get 2 x squared. And so we can write the answer like this, which kind of looks more simplified than what we have over here. So let's try one more example using the product rule. So let's say if we wish to differentiate x to the 4th ln x. Once again, differentiate the first part. X to the 4th becomes 4x cubed. Keep the second part the same, and then plus. Keep the first part the same, and then differentiate ln x, which becomes 1 over x. Now let's say if there was a 5 in front. All you got to do is put the 5 in front of everything. You can distribute if you want, but you don't have to. So we have 5 times 4x cubed ln x, and then x to the 4 divided by x is x cubed. So if there's a number out in the front here, just leave it in the front and then distribute it later if you want to. So next, let's talk about the quotient rule. So first, let's go over the equation that you need to know for the quotient rule. So let's say if you have one variable divided by another. So u divided by v. The quotient rule is v u prime minus u v prime divided by v squared. So let's use an example. Let's say if we wish to differentiate x cubed, well, let me make that yellow, x cubed plus 6x divided by 5x minus 8. So using the equation, v is going to be the same thing. It hasn't been changed, 5x minus 8. And then u prime is the derivative of that, which is 3x squared plus 6. And then minus u, which is the original x cubed plus 6x. And then times v prime, which is the derivative of 5x minus 8, which is simply 5. All divided by v squared, which is 5x minus 8 squared. Now, at this point, some teachers will allow you to leave the answer like this. Others will want you to distribute, FOIL, combine like terms, and everything else. So let's do that. Let's FOIL first. 5x times 3x squared is 15x to the 3rd power. Next, 5x times 6 is 30x. And then negative 8x times 3x squared is negative 24x squared. And negative 8 times 6 is negative 48. Let me just double check my work, make sure that I didn't miss anything. Okay, so that's it for that. Now let's distribute the 5. 5 times x cubed plus the negative sign here is negative 5x cubed. And then 5 times 6x with the negative sign is negative 30x. All divided by 5x minus 8 squared. So now let's combine like terms. We can cancel the 30x and we can combine these two. So our final answer, let's see if I can fit it somewhere here. It's going to be 15, actually no, not 15, 10x cubed minus 24x squared minus 48 divided by 5x minus 8 squared. Now sometimes you may be able to simplify this answer. You may be able to, sometimes you can factor it, factor out a GCF. If you can simplify it, feel free to go further, but at this point I'm going to stop here because I don't think I can factor that expression. At best I can pull out maybe a 2 from every term, but that's not going to do much. So that's it for the quotient rule. By the way, let's say if you see a function like this, x cubed plus 7x squared divided by 12x to the 5th. You can use the quotient rule, but you don't have to. Whenever you have only one term in the denominator, I would avoid using the quotient rule. You can separate this into two fractions. If you have like a plus 4 or another term in a denominator, you can't separate into two fractions anymore. But if you only have a single term, break into two fractions. This is the same as x cubed over 12x to the 5th plus 7x squared over 12x to the 5th. Now before you find a derivative, simplify it. So we can reduce this to 1 over 12 x squared plus 7 over 12 x cubed. Now I would rewrite it. This is the same as 1 over 12 x to the negative 2 plus 7 over 12 x to the negative 3. So now let's use the power rule. The derivative of x to the negative 2 is the same as, well, it is negative 2x to the minus 3. And the derivative of x to the negative 3, we move the negative 3 to the front, it's negative 3x, and then subtract the negative 3 by 1, negative 4. And now let's simplify. And at the same time, we're going to move the negative variables to the bottom. So negative 2 times 1 over 12 is negative 2 over 12. And negative 2 divided by 12 is negative 1 over 6. And we're going to bring the x to the bottom so that the negative 3 becomes a positive 3. So it's 6x to the third. Here we have 7 over 12 times negative 3. 12 divided by negative 3 is negative 4. So I divide it backwards, which means negative 4 is on the bottom. So what we have is negative 7 over 4, because 3 over 12 is like 1 over 4. And then x, the negative 4 is going to become positive 4 because we moved it to the bottom. So that's the answer for that example. As you can see, we avoided the use of the quotient rule. If you use the quotient rule, you're going to get an answer that is a single fraction instead of these two separate fractions. But that answer, you can break it down into those two fractions if you want. And if you want to combine that into a single fraction, just get common denominators and combine it. So now let's talk about the chain rule. We started this already, but we're going to continue it. Let's say if you want to differentiate sine x to the fourth. Start with the outside function. The derivative of sine is cosine, and then keep the inside the same, x to the fourth. Next, move on to the inside, differentiate x to the fourth, which is 4x cubed. So that's the answer for that example. So now let's say if we wish to differentiate x cubed plus 5x squared raised to the fourth power. So first work on the outside part. We're going to use the power rule. Move the 4 to the front. So this is going to be 4, keep the inside the same, x cubed plus 5x squared, and then subtract this exponent by 1, so it's now 3. And then move on to the inside, differentiate the inside. So it's going to be 3x squared plus 10x. Let's try a few more examples. So let's say if we wish to differentiate tangent sine x to the fourth. Start with tan. The derivative of tangent is secant squared. And then keep the inside. The inside part of tangent is all of that. So it's going to be sine x to the fourth. Then work your way from the outside towards the inside. So now we're on the sine. So now we got to differentiate sine x to the fourth. The derivative of sine is cosine. And the interior of sine is x to the fourth, so this is going to be the same. Next, let's differentiate x to the fourth, which is 4x cubed. So that's the answer for that particular example. Let's try this one. Let's say if we wish to differentiate sine to the third power, cosine, tangent, x to the fifth. First, I would rewrite it as sine, cosine, tangent, x to the fifth, raised to the third power. So start with the outside part. Let's move the 3 to the front. So it's 3, keep the inside the same, sine, cosine, tangent, x to the fifth. And then subtract the exponent by 1, so now it's 2. Then work your way towards the inside. Differentiate sine. The derivative of sine is cosine. And then the angle of sine is everything we see here. So cosine, tangent, x to the fifth. Okay, so we're done with sine. Now we need to move on to cosine. The derivative of cosine is negative sine, and then the inside part, or the interior of cosine, is tangent. So tangent x to the fifth. So now we're done with cosine. We need to differentiate tangent. The derivative of tangent is secant squared, and then the interior of tangent is x to the fifth. So the last thing we need to differentiate is x to the fifth, which is 5x to the fourth. That's the answer for that problem. That's a quick way of how you can use the chain rule method. So the next topic we're going to talk about is implicit differentiation. So let's say if we want to find the derivative of x cubed plus y to the third is equal to 8. In implicit differentiation, you're differentiating every variable with respect to x. When you differentiate x cubed with respect to x, you get 3x squared times dx over dx, which simply disappears. But when you differentiate y cubed with respect to x, you get 3y squared times dy over dx, which does not disappear. And then the derivative of a constant like 8 is 0. Now our goal is to isolate dy dx. So this disappears. Let's move the 3x squared to the other side. So we have 3y squared dy dx is equal to negative 3x squared. And next we're going to divide both sides by 3y squared. So therefore, dy dx, which is basically just y prime, is negative x squared divided by y squared. Let's try another example. So let's say if we wish to find the derivative of x squared plus 2xy plus y squared is equal to 7. The derivative of x squared is just 2x. And the derivative of 2xy, well, we have to use the product rule because we have two different variables. So this is going to be the first part, and this is going to be the second part. So the derivative of 2x is simply 2. And we need to keep the second part the same, so y, and then plus, keep the first part the same, 2x, differentiate the second part. The derivative of y is 1. And anytime you differentiate a y variable with respect to implicit differentiation problems, add a dy dx to it. So now let's move on to y squared. The derivative of y squared is 2y times dy dx. And the derivative of a constant is 0. Now notice that we have 2 dy dx, so we're going to have to factor it out. First, every term that doesn't have a dy dx, move it from the left side to the right side. So what we now have is 2x dy dx plus 2y dy dx is equal to, so this we're going to move to the right and that term too. So it's going to change from positive to negative. So negative 2x minus 2y. So next, let's factor out dy dx. So we're left with 2x plus 2y is equal to negative 2x minus 2y. Our last step, divide both sides by 2x plus 2y. So now we get the answer. But we could simplify it. We can divide everything by, well, let's see. Let's factor out a negative 2 from the numerator. If we take out a negative 2, it's going to be x plus y. And if we factor out a 2 from the denominator, it's x plus y. So this one, it cancels. So the 2's cancels as well. So we just get negative 1 for the derivative for that particular example. Let's try another example dealing with implicit differentiation. So let's say if you want to differentiate tangent xy is equal to 7. The derivative of tangent is secant squared, and keep the inside part the same, xy. Now we need to differentiate the inside part, so we need to use the product rule. Here's the first part and here's the second part. The derivative of the first part, the x, is going to be 1. Keep the second part the same, y, plus keep the first part the same, which is just x, and then differentiate the second part. The derivative of y is 1 times dy dx. Anytime you differentiate a y variable, add dy dx to it. The derivative of 7 is a constant, so 0. So next, we need to distribute secant squared to these two terms. So now we have y secant squared xy plus x dy dx secant squared xy. So any term that doesn't have a dy dx, let's move it to the other side. So that means this term. So we now have dy dx times x secant squared xy is equal to negative y secant squared xy. So now we're going to divide both sides by x secant squared xy. Notice that secant squared xy cancels. So our answer is just negative y over x. So that's it for implicit differentiation. Your goal is to isolate dy dx. By the way, let's say if you get to this part, dy dx is negative y over x, and you wish to find the second derivative. What you need to do is use the product rule. We know the equation is vu prime minus uv prime over v squared, where u is on top, v is on the bottom. So v is like x, so x times u prime, which is negative 1 dy dx, and then minus u, which is negative y, and then v prime is the derivative of x, which is 1 over v squared, x squared. Now what you need to do is replace, plug in dy dx for what it was here. So we now have is x, or negative x because of the negative 1, then replace dy dx with negative y over x, and these two negative signs become a positive sign, so plus y over x squared. So we can cancel these x's, so we get positive y plus y, so 2y over x squared. That is the second derivative. So whenever you want to find the second or third derivative, you're going to get a new dy dx. Plug in your first derivative into it, and then simplify. So now let's talk about the derivative techniques that we need to know for related rate problems. So let's say if we wish to differentiate x cubed, actually x to the fourth power, with respect to x. It's going to be 4x cubed times dx over dx, which is basically 4x cubed. Now, if you wish to differentiate with respect to x, let's say y to the fourth, it's 4y to the third times dy over dx. And if you wish to differentiate with respect to x, let's say r to the fourth power, it's going to be 4r cubed times dr over dx. Now let's say if we wish to differentiate, instead of with respect to x, but with respect to y. Let's say for x to the fifth power. It's going to be 5x to the fourth times dx over dy. And if we wish to differentiate with respect to y to the fifth power, it's going to be 5y to the fourth times dy over dy, which cancels, and that's just 5y to the fourth. And if we wish to differentiate with respect to y, let's say t to the fifth power. It's going to be 5t to the fourth times dt over dy. Now for related rate problems, typically you differentiate x and y and other variables with respect to time. So let's say if we wish to differentiate x to the third power with respect to time, it's going to be 3x squared times dx over dt. And for y to the third, it's going to be 3y squared times dy over dt. And let's say if we wish to differentiate, for example, this problem, volume is equal to 4/3 pi r cubed, and we wish to differentiate with respect to time. The derivative of v is basically just 1. Rewrite the constant. Well, it's going to be 1 times dv dt. Rewrite the constant, the 4/3 pi. And then the derivative of r cubed is 3r squared times dr over dt. Now let's say if you wish to differentiate a related rate problem that has two different variables like radius and height, and you wish to differentiate with respect to time. The derivative of v is 1, so we get dv dt. Pi is a constant, so we're just going to rewrite it. And then r squared times h, that's a product rule problem. So here's the first part, and here's the second part. So differentiate the first part, which is 2r dr dt. Keep the second part the same, times h. And then plus. Keep the first part the same, r squared. And then differentiate the second part. The derivative of h is 1 times dh dt. So that covers derivatives for related rate problems. Next, let's talk about how to find the derivative of an inverse function. So let's say if the function that you want to find the derivative is x cubed plus 4x squared plus 6x. How do you find the derivative of the inverse function? Here's the equation that you need. The derivative of the inverse function is basically 1 over the derivative of that function, but change x with y. So I'm going to show you two ways to get the answers. First, let's find the derivative. Y prime is 3x squared plus 8x, and that's it. So to find the derivative of the inverse function, simply put that result under 1 and change x to y. So it's going to be 3y squared plus 8y. That's how you do it. Now let me show you another way to get the same answer, and that method involves implicit differentiation. So if you want to show your work, if you feel like that is not showing work, switch x and y. So x is equal to y cubed plus 4y squared plus 6. And then use implicit differentiation and isolate dy dx. The derivative, differentiate both sides with respect to x. The derivative of x is 1, and for y cubed it's 3y squared times dy dx, and for 4y squared it's 8y times dy dx, and the derivative of 6 is 0. Now what you want to do is factor out dy dx. So we have 3y squared plus 8y, and then isolate dy dx by dividing both sides by 3y squared plus 8y. So notice that we get the same answer. Dy dx, well, dy over dx is 1 over 3y squared plus 8y. As you can see, these two are the same. Let's try another example for the sake of practice. So, given this function, y is equal to x to the fourth plus 5x cubed minus 7x plus 2. So first find y prime. It's 4x cubed plus 15x squared minus 7. So the derivative of the inverse function is simply going to be 1 over that result, but change x with y. So 1 over 4y cubed plus 15y squared minus 7. So now let's confirm it with implicit differentiation. So first, switch x with y. So x is equal to y to the fourth plus 5y cubed minus 7y plus 2. Differentiate both sides with respect to x. So you get 1 is equal to 4y cubed plus 15y squared minus 7. And I forgot dy dx, but let me add it here. Next, factor out dy dx. So 1 is equal to dy dx times 4y cubed plus 15y squared minus 7. And then divide both sides by this result, so you get 1 over 4y cubed plus 15y squared minus 7 is equal to this thing, dy over dx. So that's how you can find the derivative of an inverse function. Now, for the final part of this video, we're going to focus on finding the derivative using limits. So f prime of x can be calculated using the limit as h approaches 0 for f of x plus h minus f of x over h. Okay, so let's differentiate x squared. We know the derivative of x squared is 2x, but let's use the limit process to prove it. So we have the limit as h approaches 0. Now f of x is simply x squared, so that's going to be this part. And f of x plus h, basically you replace x with x plus h. So it's going to be x plus h squared over h. So there's two ways we can do this. We can FOIL or we can factor. We're going to do it both ways. Let's FOIL. So x plus h times x plus h. When you FOIL it, you're going to get x squared plus 2xh plus h squared minus x squared over h. Now, you need to keep rewriting the limit until you plug in 0 for h. So notice that x squareds cancel. So now we have the limit as h approaches 0. This 2xh plus h squared, but we're going to factor out h. So we have 2x plus h divided by h. As soon as you can cancel the h in the bottom, you can now plug in 0 for h. So now we have 2x plus 0, which is 2x. So that's one way to do it. Now I'm going to show you another way. Limit as h approaches 0, x plus h squared minus x squared over h. Now let's say if you want to factor x squared minus 25, how would you do it? You know it's x plus 5 times x minus 5. If you can square root both of these functions, and if there's a subtraction sign between them, you can factor it using the difference of perfect squares method. Notice that we can square root these two, and there's a negative sign between them. So we can factor it as this part, x plus h, minus that part, minus x. One of them has to be positive, the other has to be negative. So we have the negative one. Now we need the positive one, x plus h plus x, all divided by h. Now here x cancels, but here they add. So we're left with h, which is this h right here, and then x plus x, so 2x plus that h divided by h, limit as h approaches 0. Sometimes it might be easier to factor instead of foiling. So these cancel. So now we have the limit as h approaches 0 for 2x plus h. And now we're going to replace this h with 0. So we get 2x plus 0, and that's simply 2x. So now let's try a radical problem. So let's focus on the square root of x. First, let's find the derivative the easy way. This is x to the 1/2, which is, the derivative for that is 1/2 x to the negative 1/2. And if we move the negative exponent back to the bottom, it's going to be 1 over 2 x to the half, which is 1 over 2 square root of x. This is the answer that we should get at the very end. So let's use the limit process to get that answer. the limit as h approaches 0, f of x, which is just square root of x, and f of x plus h, which is square root x plus h. So whenever you have radicals separated by a minus sign or a plus sign, multiply top and bottom by the conjugate, which is the square root of x plus h instead of minus plus square root of x. Make sure to change the sign. So on the top, you want to FOIL. On the bottom, do not distribute. Keep it in its factored form. So radical x plus h times itself. The square roots cancel, and you simply get x plus h. Then these two combine. That's square root x plus h. And then these two combine, minus square root x plus h. And then root x times root x is simply negative x. All divided by what we have on the bottom. H times radical x plus h plus root x. Okay, these two terms cancel. And x minus x, they cancel as well. So we still have the limit as h approaches 0. I almost forgot to write it here. And all we have left over on top is simply h divided by h square root x plus h plus root x. So now you can cancel these h variables. So you're left with the limit as h approaches 0, 1 over the square root x plus h plus radical x. So now we can insert 0 for h. So let me continue that in the next page. So at this point we have 1 over the square root of x plus 0 plus square root of x. X plus 0 is simply x. So we have square root of x plus square root of x. Now both of these, they have an invisible 1 that we don't see. So 1 plus 1 equals 2. So 1 over 2 radical x, which is the answer that we had previously. So whenever you're dealing with radicals and limits, multiply top and bottom by the conjugate of that radical. So our next example would be differentiating 1 over x. So let's use the power rule. We can rewrite this as x to the minus 1. And we're going to move the negative 1 to the front. So negative 1x, subtract the exponent by 1, negative 2, then bring it back to the bottom. So this is negative 1 over x squared, which is the answer that we should get for this example. Okay, so let's use the limit process. So the limit as h approaches 0, f of x is 1 over x, f of x plus h is 1x plus h. So here we have a fraction within a fraction. Whenever you see a math problem like this, multiply top and bottom by the common denominator, which is basically these two. So times x, x plus h, and then x, x plus h. So this term times x, x plus h, what cancels? You can see that the x plus h cancels, leaving behind only x. And then we have a minus sign. Next, we're going to multiply this term times x, x plus h. So what cancels? We can see that x cancels, and that leaves behind x plus h. On the bottom, don't distribute. Keep it in its factored form. H, x, and then times x plus h. And then we need to rewrite the limit. So here we have x minus x. Those two cancel. So we're left over with the limit as h approaches 0. Now we still have to distribute this negative sign to the h. So we have negative h over h, x, x plus h. So now we're going to cancel these two h's. So we have the limit as h approaches 0, negative 1 x, x plus h. Now that this h is gone, we can replace or plug in 0 for h. So we're going to insert 0 here. So we don't need the limit anymore. So now we have negative 1 x, x plus 0, which is negative 1 x times x, which is negative 1 over x squared. And that's the answer for that example. So whenever you have a fraction within a fraction, multiply top and bottom by the common denominator of those fractions. So our last example would be the limit process of a cubic function. So we know the derivative of x cubed is 3x squared. So let's prove it using limits. So the limit as h approaches 0 for x cubed and f of x plus h is going to be x plus h to the third power. Now we can FOIL x plus h 3 times. We can do x plus h times x plus h plus times x plus h. But personally, I think that's going to be a long time, and I think it's easier if you factor it using the difference of perfect cubes. The equation is this: a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So keep in mind, a is x plus h, b is x. So we're going to use the right side of this equation. So we have the limit as h approaches 0, a minus b. So a is x plus h, and then minus b, which is simply just x, and then times a squared, which is x plus h squared, plus ab. So a is x plus h, and b is x plus b squared, which is just x squared, all divided by h. So x minus x will cancel, and then we're going to have just this h by itself, which we can cancel these together. So now that this h is gone, we can plug in 0 for every h that we see. So it's going to be x plus 0 squared plus x plus 0 times x plus x squared. X plus 0 is x, so we just have x squared. Here we have x plus 0, which is x times x, that's also x squared, plus another x squared. So there's an invisible one that we don't see. 1 plus 1 plus 1 is 3, so we get 3x squared. That's the answer.